Completing the square method is a longer way of solving a quadratic equation, but it does work with every single quadratic equation. You can always solve any quadratic equation using completing the square method, and you can always solve any quadratic equation using quadratic formula as well. Certain times in math, especially when working with conics, you will need to learn how to complete the square. Or in certain integral problems, you will need to use how to complete the square. So it's an important method, but if the problem doesn't say which method to use uh, for solving a quadratic equation, I recommend that you use quadratic formula. Only use completing the square method when it's absolutely necessary or when the problem states itself that use completing the square method. So first step would be we want to write the equation in the form ax squared plus bx equals negative c. We want to take the constant term to the other side. If a is not equal to 1, which means the leading term is not equal to 1, we want to divide everything on both sides with that a to make the leading term 1. Then we add half of b squared, the quantity half of b squared will be added to both sides of the equation, complete the square, and then use square root property, isolate the variable. That being said, these problems are easier when your leading coefficient is 1, but when the leading coefficient is something other than 1, they are a bit extra work because you have to make sure the leading coefficient is 1 before you can complete the square. So let's look at some examples. The very first one, we do have leading coefficient as 1, and we already have the constant on the other side. So my b here, b is the term with the x. We're going to add 1/2 b squared to both sides. So in this case, it would be 1/2 times 12 squared, which is 6 squared. So x squared plus 12x plus 6 squared equals negative 8 plus 6 squared. Instead of writing 36 in this first step, I prefer writing 6 squared because in the next step, I'm going to complete the square. We bring the x into the parentheses, we bring the 6 into the parentheses, and we bring the sign of the middle term in here, and that's the perfect square we have on the left-hand side. If you think, oh, what happened? We went from trinomial to a binomial. On a scratch space, you can always do x plus 6 times x plus 6 because that's what x plus 6 squared is, and that is going to give you x squared plus 12x plus 36. So we did not really lose any terms. We just rewrote it as a square of a binomial. On the right hand side, we have 36 minus 8. That is going to be 48. So 36 minus 8 would be 28, not 48. Okay. So now we have something, a quantity squared equal to a number. We're going to go ahead and take square root on both sides. Square root on both sides. So when we take the square root on the left hand side, this is x plus 6. When we take the square root on the right hand side, that is square root of 28. Lastly, we want the x to be by itself, so we're going to go ahead and subtract 6 from both sides. So negative 6 plus minus square root of 28. This is not in the simplified form. We can think of break the 28 into 7 times 4 and take the square root of 4 outside. So negative 6 plus minus 2 root 7 is going to be, these are going to be my two solutions, negative 6 minus 2 root 7 and negative 6 plus 2 root 7. Okay, the second problem we have, x squared minus 6x equals negative 1. I already have the constant term on the other side. The b is negative 6 here. So 1/2 times negative 6 squared, which is negative 3 squared. And negative number squared is going to be positive. So I'm going to ignore the negative. We will always add this extra term we are bringing. We're always going to add it to both sides because when negative is squared, it turns out to be positive. So 3 squared equals negative 1 plus 3 squared. Inside the parentheses, an x comes down, a 3 comes down, and the sign of the middle term comes down. And middle term has a negative sign here. And again, if you FOIL this, you will get that initial trinomial back. Negative 1 plus 3 squared is 9 minus 1, which is 8. Take square root on both sides. So when we do square root on both sides, left-hand side, square root and square will cancel. Right-hand side will be left with square root of 8. X is 3 plus minus square root of 8. Again, when we simplify or break apart the square root of 8, it's 4 times 2. We can pull a 2 out. And it's 3 plus minus 2 root 2. y squared plus 11y plus 49 equal to 0. Step number 1 is to move the 49 on the right hand side, and I left some empty space before I put the equal sign. This is where I'm going to figure out what number should be added to both sides. And we just saw it's half of the middle number, and in this case it is just going to be 11 divided by 2 squared. It's a fraction, and that's okay. When we complete the square, we bring the y, we bring the 11 over 2, we bring the sign of the middle term. Entire parentheses is squared. We have negative 49 plus 121 divided by 4. Now on the right hand side, we're going to combine the like terms. We're going to multiply negative 49 with 4 and add 121 to it. So 49 times 4, and then add 121. And we're going to have negative 75 divided by 4 on the right hand side, and left hand side would be y plus 11 over 2 squared. It's time to take square root on both sides. When we take the square root, we always add plus minus in the front. So left hand side, square root and square cancels. Right hand side, we are left with plus minus square root of 75 divided by 2. Square root of 75 can be simplified. We can think of 75 as 25 times 3, so we can pull a 5 out. Y plus 11 over 2 equals plus minus 5 root 3 divided by 2. Lastly, moving the 11 halves to the right hand side by subtracting 11 over 2 from both sides, so negative 11 plus minus 5 root 3 divided by 2. There's my two solutions to this equation, quadratic equation. These solutions are also called x-intercepts or roots or zeros of or solutions of the equation. Next example, x squared minus 5x equals negative 22. I already have the constant term on the other side, so we're going to go ahead and add half of the middle term squared to both sides. Left hand side, we bring the x in the parentheses, 5 halves in the parentheses, and the negative sign in there. And right hand side, we just have to simplify the fraction. So x minus 5 half squared equals, now on the left hand side, we do need to get the common denominator to be able to add these fractions. So we can have negative 88 plus 25, and that's negative 63 divided by 4. Let's go ahead and take square root on both sides. When we take the square root, we're going to put plus minus in the front. Left hand side, square root and square cancels. On the right hand side, we're going to have an I, because we have negative inside the square root. I root 63 divided by 2. Square root of 4 is 2. Square root of 63 is 9 times 7. It looks like I can pull a 3 out, which is square root of 9 out. So also add 5 halves to both sides. 5 halves plus minus I. We can pull a 3 out, square root of 7 stays there. So rewriting it in a bit cleaner form, or we can write it as a single expression. 5 halves plus minus 3i root 7 divided by 2, or 5 plus minus 3i root 7 divided by 2. There's our solution to this quadratic equation. We solved it using completing the square method. I have a separate video completing the square method and coming up with quadratic formula. How do we complete the square on a quadratic equation in the standard form? But that's not discussed in this video. See, next example, we have something slightly different here. My leading term is not equal to 1. For us to be able to complete the square, the leading term must be 1. So right away, I'm going to go ahead and divide everything on both sides with the leading term to make that leading term equal to 1. X squared plus 4x plus half equal to 0. 0 divided by 2 is still 0. X squared plus 4x equals negative half. Move the constant term to the other side. Now I'm thinking about the middle term is b, which is 4. If I cut it in half and square it, that is just going to be 4 divided by 2 is 2, 2 squared. So we're going to go ahead and add 2 squared to both sides. Turns out to be x plus 2 squared equals negative 1 half plus 4. X plus 2 squared equals, we do need the common denominator, which is going to be 8 minus 1, 7 over 2. It's time to go ahead and take the square root on both sides. When we take square root on the right hand side, don't forget the plus minus sign. That's from the square root property. Left-hand side, square root and square cancels each other. We are just left with square root of 7 over square root of 2. We don't want to leave a radical in the denominator. It's a common practice in algebra not to leave a square root or any radical in the denominator. So we're going to go ahead and rationalize, and that would be square root of 14 divided by 2. We rationalize by multiplying both numerator and denominator of right-hand side with the same radical as the denominator. This way I have no more square root in the denominator. Lastly, I need to get x by itself, so I'm going to subtract 2 from both sides. Now, this doesn't look like a cleaner way of writing my answer. I'm going to get it as a single fraction, so we'll have to multiply the first fraction, numerator and denominator, with the 2. Turns out to be negative 4 plus minus square root of 14 divided by 2. There's our two solutions. That's all for this video. In the next video, we're going to see some literal equations that we solve using quadratic equations, and we'll look at applications of quadratic equations.